Hey guys, welcome back to the channel, New Generation HVAC. In this video, what I want to go ahead and go over is the state, the pressure, and the temperature of the refrigerant. Now, if you could go ahead and see clearly on the whiteboard, I've done something different. What I did was I covered some of the states, some of the pressures, and some of the temperatures of the refrigerant as it's flowing through my refrigeration system. Little by little, I'm going to start revealing the different answers, and we're going to go ahead and put the pieces together as to how the air conditioning system is working, where my refrigerant is changing from a state of liquid to vapor and vapor to liquid. Now remember, our four major components once again are my compressor, my condenser, my metering device or my TXV, and my evaporator coil. Now whenever we follow the flow of the refrigerant in my refrigeration cycle, I'm always going to go ahead and start with my compressor. So let's go ahead and start with my compressor. Whenever my compressor is pumping out the refrigerant, remember it's always pumping it out in the state of vapor. All right, so then we could go ahead and reveal this one right here. So as it's coming out through my system, it's coming out in the state of vapor, right? So vapor, at what pressure? Well, it's at a high pressure. And at what temperature? Well, it's at a hot temperature. And we could see that because of my temperature coming out of my compressor. This line right here, once again, is known as my discharge line. So my discharge line is at a temperature of 160 degrees. So that right there, once again, is at a very hot temperature, very, very high temperature. As it's going into the system, it's going to go into the entrance of my condenser. And what's going on is, as you could see about right here in this part of the section, the temperature of my refrigerant is at about 105. So it's lost temperature, right? It's cooled down a little bit. It's not as hot as what it was, but it's cooled down. And as it keeps cooling down, what happens to the state of my refrigerant? Well, the state of my refrigerant changes from a vapor to a liquid. That's why, as you can see here, it's starting to change and it's starting to get darker in color. It's traveling into the condenser. It's continuing to travel into my condenser coil, and then it goes into this line right here. This line right here, all the way to my TXV, is a very important line. Now that line is right here. So let's go ahead and reveal that line, all right? That is known as my liquid line. As you can go ahead and see here, the state of my refrigerant now is in the state of liquid. So we started off in the state of vapor, and now we're all the way over here in the state of liquid. But pay attention to this, very, very important. Look at the temperature of my refrigerant. It's 105 degrees. As it's continued to travel through the condenser coil, by the time it reaches this section of my refrigeration cycle, let's go ahead and reveal what temperature the refrigerant is at. So the temperature of my refrigerant is at about 95 degrees. So you see how it started off at 160? Now it dropped to 105. As it keeps getting a little bit cooler, right? It's dropping down to about 95 degrees. So about 95 degrees is what it's probably entering my TXV. Now as it's entering my TXV, it's in the state of, once again, state of liquid. As it's entering the TXV and it's coming now, it's still in the state of liquid. But there's something very interesting happening, all right? So as it's traveling into my TXV and, into my TXV and then out of my TXV, it's traveling in through here. The state of the refrigerant is starting to change very, very little. The majority of it is still in the state of liquid, but then we have something like this going on. Check it out. Right here, what starts to happen as it starts to enter into my evaporator, the refrigerant starts going in through a process called flash gas. What that means is that 80% of it is still in the state of liquid and 20% of it is now in a state of vapor. So the state of the refrigerant is starting to change a little bit sooner because it starts to boil off a little bit sooner. It's starting to pick up heat a little bit sooner. Remember, over here, the pressure is a lot higher. So over here, as you can see, the liquid refrigerant is at a high pressure, but at a warm temperature. Once again, compared to high pressure, hot temperature, we have high pressure, warm temperature. It goes into my TXV. The TXV is lowering the pressure. It lowers the temperature. It goes and it starts coming out as a flash gas, 80% liquid, 20% vapor. And now we have low pressure. And then what's the temperature of my refrigerant? Is at a cold temperature. So why do we need it to be cold? Once again, my refrigerant needs to be brought down to a cold temperature in order to absorb heat. So at what temperature is my refrigerant going into my evaporator? Well, let's go ahead and reveal this one right here. So check out the temperature of my evaporator. The temperature of my evaporator is about 40 degrees, right? So it's going to drop to a cold temperature, but I don't want it to drop too low, because if it continues to drop too low and it drops below 32 degrees, then my water is going to go ahead and start to freeze. But it's going to go ahead and continue into my evaporator, and you can see where you have this flash gas going in. And what's going on is, as you have the hot indoor air come in contact with the coil and the refrigerant is now starting to absorb the heat and it's starting to boil. And as it's starting to boil, the state of change is starting to happen again from a liquid to a gas, right? So now it's going into my evaporator, and it's going all the way across. And remember this right here, as you have a change of state happening where liquid and vapor exist in the same place at the same time. That right there is known as my saturation temperature, my saturation line set. About right here is where I have in this point of my evaporator starting to change state, and as it goes back into my, in this case it's known as my suction line, and it goes back all the way into my compressor in the state of, once again, vapor. So now what is the temperature of my refrigerant going back into my compressor? So now I know it came in as, at the temperature of 40 degrees. It picked up heat coming back into my condenser at about 55 degrees. You see that? So at about 55 degrees, that temperature is coming in back into my compressor. My compressor is picking up the temperature. It picks up the temperature. Why? Because as you can see here, it says heat is transferred from the refrigerant to the outside air. So the outside air is cooler than my 105 degrees or my 160 degrees. It comes in contact with the coil, and then as it comes in contact with the coil, it absorbs the heat. The air absorbs the heat that the refrigerant had absorbed over here. That's why it says over here, heat is transferred from the inside air to the refrigerant, and over here, heat is transferred from the refrigerant to the outside air. Now, the last thing for us to reveal is the state of my refrigerant coming back into my compressor. Not only the state, but the pressure and the temperature. Let's go ahead and reveal the last one right here. So as we go ahead and remove this right here, you can see the state of my refrigerant is in a state of vapor. Pressure remains low, but look, it's a little bit cool. It's not as cold because it absorbs a little bit of heat, but it's cool, right? So now, as we see the whole entire picture, let's go ahead and go over it all together. And my compressor, that's where we're going to go ahead and start on my basic refrigeration cycle. I'm going to go ahead and have the compressor compress the refrigerant. Once again, the compressor does not compress liquid refrigerant. So the state of my refrigerant leaving and entering the compressor should always be in a state of vapor. So the compressor is compressing the refrigerant, is picking up the temperature, and it's bringing it into my condenser. The air from the outside, as the fan is turning, it's passing it through these coils, and that outside air is now absorbing the heat. So as you could see, the refrigerant cooled down to about 105 here, and then it started cooling down even more, and it started to change state from a gas to a liquid, and then it goes all the way into my TXV, and this right here is known as my liquid line. And look at the temperature of my refrigerant, 95. The state is a liquid at high pressure, warm temperature, high pressure, hot temperature. So now as it goes into my TXV, I have my TXV, right? There's a spring here. There's an action, a type of like a little spring action that's going on here that is allowing just a little bit of amount of refrigerant to travel through, but it's still traveling in a state of liquid, is dropping pressure, is dropping temperature. So that's what my TXV does. It drops pressure, it drops temperature. So now it goes into my evaporator and it's entering in a form of flash gas. Once again, it's still liquid, it's still in a liquid form, but it's 80% liquid and it's 20% vapor. So it's starting to go kind of, gather a little bit of heat, but not enough to change it completely into vapor. The temperature of my refrigerant is now going in at 40 degrees. So very, very cold, right? In this case, in order for it to go ahead and absorb heat from your inside air, it's going into your coil. The inside air is passing through the coil, and then as it's doing that, it's absorbing heat, so it's going into another change of state from a liquid to a vapor. It's coming out of your evaporator into the suction line, and now it's coming back as a vapor, low pressure, as a cool temperature. Here we have cold temperature, and then it picked up heat. Now that's why it's at a cool temperature. It went from a 40 degree refrigerant to a 55 degree refrigerant. So we could see the difference, right? We could see how it rejected heat, how it got colder, in this case, how my refrigerant got a little bit cooler, or it cooled down a little bit from 105 to 95, and then it heat up a little bit, and then it heat up a little bit where it went from 40 degrees to 55 degrees. And this, as you can go ahead and see, is what is the state, the pressure, and the temperature of my refrigerant in my refrigeration system or in my air conditioning system. So now we go ahead and we put all the pieces together. We have my saturation temperatures, we have my state of my refrigerants, my high pressure, low pressure, I have my high side, and I have my low side. side. So as you can see here, this right here is the basic cycle of refrigeration put together. If you have yet not seen my previous videos, I encourage you to go see the previous videos. Like that, you go ahead and see how I break down all this into those other videos. In this video, what I'm actually doing is putting all the pieces together. We have the four major components. We have the high side and my low side of my system. We have where we talk about absorption and rejection of the heat, and we see it clearly on the temperatures and on the state of the refrigerants. And we also see how we have my saturation temperatures where it changes, in this case where my refrigerant changes from a gas or a vapor to a liquid, and from a liquid to a vapor. So I want to go ahead and thank you for sticking around in this video. If you like it, go ahead and leave a thumbs up. Subscribe for future videos. Like that, you won't miss the next videos for your HVAC technician journey. And I'll see you on the next one.